Rob Monday, David Cullen, welcome to the Rotary Wing Show.
Awesome. Thanks for having us.
Yeah, thanks for having us, Mick. Appreciate it.
Brilliant, guys. Well, you guys are from SR3 rescueconcepts.com is the website, and we'll come back to that at the end. But essentially, we're going to talk a whole heap about rescues and sling ops today. So we might just, initially dive in. The easiest way will just be to get a quick background and give some context, and then we'll get into some of the content. So, Rob, do you want to give us a quick walk down of how you got into helicopters and what you're up to at the moment?
Yeah, absolutely. So I think it was actually a little bit by chance, I suppose. I finished high school, didn't really know what I wanted to do, and ended up in the Victorian snowfields doing a diploma of outdoor education, which ironically helps me out a lot now. And then it kind of got me through looking for summer work. I ended up doing some seasonal stuff, firefighting on a rappel crew down in Victoria in Australia, and then ended up transitioning across to Canada and basically working back and forth seasonally on a rappel crew in Canada as well. So I was transitioning back and forth and worked my way kind of through the ranks there. And I did 10 seasons in the end of firefighting, which was fairly significant overall. I ended up in Queensland for a little bit. I went to Careflight. I don't want to plug too much, but I went to Careflight. They did a bang-up job. I did an introductory crewman course with them and was interested in getting more into the aircraft side of things. Yeah, then basically started knocking down some doors. I was lucky enough to walk into the RACQ Capricorn base in Rockhampton. And the timing was right. I got lucky up there and ended up working there for a couple of years. It was a single pilot IFR operation. We did NVGs. It was a dual role. So we did rescue swimmer. We did a hoist operator. So an air crewman role, rescue crewman role there. As fate would have it, I ended up back in Canada and ended up marrying my lovely wife over here now. But yeah, we ended up finding some work over here, doing some marine pilot transfer stuff. We ended up doing the first marine pilot transfer program up on the north coast of British Columbia in Canada. That was 2 years of that, pretty much every day, out hoisting to some boats. And now I'm working with Blackcomb helicopters down in the Sea to Sky area, so Vancouver and north of there, just helping them with getting their hoist program up and running. We're doing some search and rescue stuff, some power line maintenance, and a whole bunch of other things on the side. And then obviously I'm now doing a little bit of work with SR3 as well as an instructor with them when they have courses going on, just to keep the tool sharp, so to speak. That's about it.
And Rob, I was going to say, going through that, how much of that was formal training and how much of it was just on the job? This is how you do that particular operation.
Yeah, totally. So I think when I showed up, for rappel training in Australia, it was a three-week rappel course, which gives you quite a good introduction to the flight side of things and the aircraft side of things. It's fairly introductory, but it gets you going. And then beyond, that's kind of on the job, I suppose. That wasn't out of my pocket. And then likewise with the rappel stuff in Canada, a lot of that was on the job. 3 to 4 weeks of initial training, and then on the job beyond that to get through to those dispatcher type crew chief roles with that program. I did pay for a 2-week course in Queensland at Careflight, and that was the only training I've ever actually really paid for out of my own pocket. All the training in Rockhampton was on the job when I first showed up there, and then continuing from there. We were given some training when I started in Canada with the marine pilot stuff. That was all on the job training, but the client ended up footing the bill for that, which was great. And then all the stuff at Blackcomb, I'm the one providing the training to other people now internally there. So that, not all was actually paid for by me.
No, that's right. I was more along the lines of, was it, formal training in terms of here's the training syllabus, or was it sort of, you're working with people and they're showing you on the day, okay, this is how we do the actual operation.
Yeah, exactly. It's kind of a combination of both, I suppose.
Awesome. Okay. And Dave, you're a front seater. Well, your sort of background then in terms of getting into the industry on your side?
Yeah, so on my end, just kind of grew up around aviation, and my dad actually was a patrol pilot and a rescue pilot for LA County Sheriff's Department back in the day. So always looked up to my dad, and it was always a long-term goal of mine to try to do the exact same thing. So I basically started flying airplanes in the early 90s and got my private single and multi-engine land rating, and then eventually got my instrument rating. So just kind of flew airplanes recreationally for a number of years, and then I eventually hired on with Las Vegas Metro Police in the beginning of year 2000. And Metro has an aviation unit, so my goal was to eventually become a pilot there and then work my way up to do rescues. So 2007 was able to transfer to the air support unit, went through the general course that the agency does all the training in-house. So got my private, got my commercial, eventually got my CFI, got my night vision goggle instructor endorsement. And then after a number of years, I got trained to start flying rescues. And the rescue ops initially that we were doing were hoist operations in HH-1H Hueys. And then we also did and still do a lot of light rescue operations in the MD-500s, mainly the F model. So a lot of that's like one skid, tow-in type rescues. Also did quite a bit of short haul in the 500. A few years ago, we acquired an Airbus H-145. So now all of our hoist work is done in the 145. And then in addition to that, kind of eventually ended up becoming the safety pilot for the unit. And then also the CFR Part 133 chief pilot of external load ops for the agency. That's basically it. So it all kind of started with my dad as an inspiration, and now I'm doing the same thing he did a number of years ago.
He would have been pretty stoked, I imagine, to see you sort of getting into the same or similar organisation.
Yeah, he is, and we talk about it all the time. Actually, I was talking to him about it this morning, and it's cool. He's super proud, and it's cool to follow in his footsteps. So,
did you do 7 years as a beat cop to get into aviation? Is that about right?
I did. Yeah, I actually did. That's a requirement with the agency. You have to have a number of years as a regular patrol officer to be able to test to go to the air support unit, because the focus is patrol flying to support the patrol officers. So that's the main goal. So yeah, you have to have that experience as an officer to eventually transition over to the unit.
There's a book out there. I think it's written by, is it Kimball? I'm not too sure, but he went through a police officer. I think he was in LA, and went through. I've got to track him down. I think he still does talks for police agencies and that. But yeah, he describes the thing too. He just wanted to fly, and he just had to suck up the ground roll and just keep applying until he got through on the air police side.
Yeah, and it's basically in most police departments, that's how it is if you want to get into their aviation unit. And I can tell you honestly, I hired on with the agency to be a patrol officer. Really that was kind of the main goal. And then if I could eventually get into the air unit, that was my long-term goal. But essentially I hired on to be a patrol cop, and enjoyed every minute of it. It's a blast. It's definitely a unique career. It's very rewarding. It's a lot of fun. So, at times I actually miss it. But the cool thing is, you actually get to participate in that role. You're just doing it from a helicopter at altitude instead of in a police car, but you're basically doing the same job. It's just a different way you go about doing it.
All right. Well, look, I'm sure there's a whole interview I'd love to do just around on that sort of police ops flying things. But I guess at some point you got out, and Jason, who's not here on the line with us today, is again another one of the partners there at SR3. Can you give just a quick intro to Jason and how you guys got into your current role?
Yeah, so Jason and I actually hired on the same day, and we were in the same police academy. We actually sat next to each other, which is pretty funny, but we became very close friends. And he transferred up to the search and rescue section not long after I came up to the air support section. So he basically became the senior search and rescue officer after a number of years, and he's really passionate about training. He likes to stay abreast of all the current techniques, and just really, really super good guy, and just really cares a lot about the job and the people he works with. So we got to work together, for a number of years in that role. Essentially, the company was founded because we had a very close friend, one of our best friends named Dave Van Buskirk, who was also a search and rescue officer in the unit. And in 2013, we actually lost him. He fell on a night hoist operation up in Mount Charleston, and he unfortunately fell to his death. And the accident was basically a dynamic roll-out incident with the hook. So, obviously, really, really difficult loss for the agency and all of his friends, and especially his family. But Dave was probably the most talented and compassionate officer that any of us had ever worked with, and he was just extremely good at his job and really set the standard for everybody in the agency, especially in the SAR unit. So after it occurred, after a couple of years, Jason and I were just kind of saying, man, we would really like to eventually start a training company and try to, prevent any accident from ever happening again, so nobody ever has to experience this. It's kind of off the thought if it's predictable, it's preventable. So that was really the catalyst, and the company is named after Dave's call sign. His call sign was SR3, And so that's essentially what we did. The company's founded in Dave's honor.
And that's a pretty good story to lead into things and that. We're going to jump all over the shop, and I did have some notes there, but I guess if people cut out at this point and left with nothing else, Rob, do you want to just introduce dynamic rollout and what it is and what, if you take nothing away from this lesson or this sort of interview, how do you stop dynamic rollout?
Yeah, for sure. I think there's two parts to it. Obviously, the equipment that you're using plays a big part, and then also the way that you use it as well. So dynamic is effectively it's a two-part thing. It's the ability for the equipment that you're using to actually get into a position on the hook where if it's weighted in the incorrect way, you can actually push the gate of the hook open and you can fall out of it effectively. So there's, like I said, there's two parts of it. If the equipment that you're using is physically unable to roll over into that position due to the geometry of the hardware that you're using between the hook and the whatever is beneath it, then you've kind of eliminated part of the problem by not having that available to you as an option. And then the second part of it too is the type of hook that you're using, and there are certain hooks out there. One in particular that almost totally eliminates that possibility. I think there's a brand new version of that hook coming out shortly, and that as far as we can tell is going to totally eliminate the possibility of that happening. And unfortunately, there's a lot of guys still out there now that, again, maybe don't know or don't have the ability to change that equipment over. But in terms of an investment in the future, it's one of the cheapest things you can do to change the hook that you're using. And then no matter what gear you're going to be using in the future, it almost makes that foolproof in terms of being able to roll out of the gear.
Now, Rob, I'm going to take the side of the everyman pilot here who doesn't know anything about sling hooks and try and explain that. And I'm going to wave my hands here in front of me to describe it. For someone who's got no background to it, we're talking about the hook that goes on the end of the wire down from the winch. And you would normally put like a D-shaped kind of shackle through that. And I guess if you're talking like a sling, you might have two of those go through that hook. And normally there's a gate that would then close that hook off to stop the D-shackles falling out. But you can get a situation where if you twist the sling or twist the D-shackles around, they kind of grip and climb up on each other and climb up the side of the hook towards the gate and can then actually roll and disengage the gate and come off the hook. That's essentially what we're talking about.
Yeah, that's absolutely right. Yeah, and to help visualize it too, I know you're a fan of the show notes. We can definitely put a link up to a short video in there demonstrating exactly what that looks like if you'd like.
Yeah, that'd be perfect, just to give people an idea. Because again, it's just for a lot of people, it's a new term, and
it's hard to visualize it. So.
Yeah, and we hear
the same thing can actually happen. The same thing can happen with the belly hook on the aircraft too. Some cargo hooks under your aircraft are actually able to do the same thing potentially.
Sure. All right, well, let's dive into our kind of little outline we had. Why is slinging such an important thing for helicopters in terms of what it gives us an extra capability? I guess we didn't discuss who was going to. I was going to say we probably didn't break up who's going to take it, but yeah, sure. Rob, do you want to tackle that one first?
Yeah, sure. I can start off. Yeah, so I think there are some advantages to it, obviously. The big one for us in a lot of the places we go is the reason why we're hoisting is because there is no place available to land. If the safest option is to land or to perform a hover exit operation or something like that, if that's the safer option, then that's what we're going to do, right? We're not trying to be rock stars here, and we're not trying to make things harder than they need to be. But there are times when you aren't able to land, and therefore you have to look into some kind of external load operation like a hoist or like a long line type rescue with a fixed rope under the aircraft. The advantages of the hoist obviously are that you're able to change the length of that line infinitely between 0 and, well, for most aircraft up to almost 300 feet. So there's very, very few situations where 300 feet isn't enough. But if you're using a long line, you either show up with 300 every time or you have to change that line suit the situation, which if you're going out on a rescue, you don't always know what that situation is going to be. So the ability to arrive on scene, you don't have to actually land the aircraft. You can crack open the doors, you can take a look at what you're dealing with, and you can basically make a plan to deal with the situation, whatever it is on the day. If you've flown 100 miles to get out there or you're going offshore or something like that, I mean, yeah, it really is. It really is a no-brainer in terms of the options. A lot of the hoist-equipped aircraft have some twin-engine capability as well. So some may not be able to hover on one engine once they're actually arriving on scene, but the entire transit time back and forth are quite often a kind of secondary benefit of that hoist is that it comes on an aircraft that's much more capable. But then if you arrive on scene and you have that one engine in operative capability and you can actually maintain a hover in the event of an engine failure, then clearly the safety benefits are exponentially increased at that point. A lot of hospitals, helipads and stuff like that have restrictions on what you can actually land on them, especially if they're in built-up areas. So twin engine Cat A for the pilots out there, stuff like that is a huge benefit as well. And I'm sure Dave can speak a little more to that one. But I think it's just the ability of flexibility. You can arrive on scene and make a plan, and more often than not, you can solve the problem with the equipment that you have on hand.
And Dave, as far as history wise, there's a couple of notes there. I'm not sure if you wrote those or if Rob wrote the history side of slinging.
Yeah, so essentially the first hoist rescue was in the 1940s, and it was actually Igor Sikorsky that did it in Connecticut. There was a sinking barge that some folks needed to be rescued from, and he was able to fly out there and actually successfully pluck some people off of the sinking barge. So that was the first, as far as documented helicopter hoist rescue. And it's evolved since then over the years as the aircraft have become more capable, the technology and the equipment has become more capable. But it really started to ramp up in the 50s and 60s all around the world, and pretty widespread today, I would say, all across the world. A lot of people do either a combination of hoist or short haul type rescues with a fixed long line beneath the aircraft. But there's a lot of applications for it. I think the most widely used application is pretty obviously in search and rescue. There's also applications for it in power line type utility work and things of that nature. But as Rob said, it gives just a lot of flexibility to be able to put people and equipment in and out of very inaccessible areas. And the nice thing about hoisting is it's not a rushed procedure. If it's done properly, it should be very slow, very methodical, very planned out. So there's a lot more control over the ability to bring the people in and out, in my opinion, as opposed to a short haul, which there's nothing wrong with short haul. But, if you have the ability to actually bring people up and down from the aircraft at the speed that you want to, it just gives you a lot more flexibility and options and then increased safety.
I think from my perspective, with a whole bunch of experience in the rappel side of things, I mean, for anyone that doesn't have an understanding of rappelling, you're descending on a rope. And I mean, compared to the hoist, that's a one-way ticket, right? Like you're going down and there is no up in that particular thing as well. A lot of people are using rappelling as an option for deployment as well. And in that case, I mean, to be able to double your options and actually come back up to the aircraft again is a huge one as well.
Dave, when you're talking short haul, you're talking about basically a long line under the belly hook, and you're basically picking up, moving the people just to a safe location and then landing and then putting them in the aircraft from there.
Yeah, exactly. And it's a fixed line, so it's attached to a hook on the underside of the aircraft. And then there's a secondary safety device, usually either a second hook or what they call a belly band, which is a device that would wrap around the underside and then come into the cabin of the aircraft and then be secured so that if the primary hook were to fail, then the secondary hook would catch the load as a backup. But yeah, it's anywhere from industry standards, anywhere from 100 to 200 foot fixed line. And people and equipment can be picked up and flown directly in and out of areas that way. But as I mentioned before, that's a fixed line. And as Rob said, you just can't bring people up or down. They're just suspended below the aircraft. So, having the ability to bring somebody up if there's a problem, get them back into the aircraft is a huge advantage. And, as well, if you fly into an area and maybe the conditions aren't what you expected, maybe the wind's picked up, or it's going to be a little bit more challenging for the pilot to maintain some stability and control. Well, if you have a short haul, you have these people or gear, suspended beneath the aircraft. Whereas with a hoist, you don't even have to lower anybody out. You can maybe try some different approaches or, look at some other options. You don't even have to initiate the hoist. So just some differences between the two techniques. But it's just nice to be able to not have to put anybody below the helicopter until you're ready to, essentially, when you get on scene.
All right, in Australia, is again, a fair bit of restriction around it in terms of qualifications, equipment and all those sort of things. So I'm imagining it's a little bit similar elsewhere. It's not something you're just going to go out, in an aircraft and try for the first time with whatever gear you can pick up. So what are some of the legislation requirements around conducting sling hops?
Yeah, so Rob, I think you'd probably be worth mentioning. I'll let Rob discuss a little bit in Canada because it's interesting. There's differences between the countries, and Canada is a little bit more restrictive. So I'll let Rob take that question.
Yeah, I certainly think there's some huge differences, and I mentioned this in my notes here. Is like depending on who you are and where you're from the aspect of receiving training in these operations. Either you need to be really, really, really sure that you're on top of what the regulations allow you and do not allow you to do. Otherwise, you can find yourself in real trouble. I mean, for example, in Canada, there's a couple of really critical things that we need to pay attention to if we are going to do any short haul or long line type stuff, which I don't want to get into too much, but you do need to have that belly band or some kind of second hook underneath the aircraft. It's not a matter of just clipping a rope into the belly hook and off you go. You can't do that. It's not legal here. So that's obviously a restriction which doesn't exist down in the US. They're able to, it's not advisable, but they're able to just clip straight into the belly and go to work. Especially with hoisting in Canada, for anything what we would consider to be work access, so basically anything that's not an emergency services operation, so things like power line maintenance and the marine pilot transfer stuff that I was working on as well, you do actually have to legally have that one engine inoperative hover performance in order to perform that work. You're not allowed to physically go out in there and do it in either a single engine aircraft or a twin. For example, some of the less powerful Bell mediums and stuff like that, you're not actually allowed to go out and do it in those unless they can have a chart that allows them to perform that operation with one engine inoperative, which is a challenge. That can get costly and it can get really restricted sometimes in terms of where you can actually go out and do this work, especially if it's not for rescue. If it is for rescue, then you're allowed to go out and do it in single engine aircraft, and that makes things a little less restrictive. But things like equipment have fairly large restrictions on them, which don't exist down in the US. In Canada, we have to have approval for every piece of equipment for each aircraft that we operate. So it's not a matter of just walking into the local rescue store and buying some harnesses and going to work. And I think Dave can maybe speak to the US side of things a little more, but that certainly is not anywhere near as restrictive down there in terms of what they can do.
Yeah, and that's essentially the way it is in the US. The industry is regulated, just not as strictly. And one good example of that is, like Rob had mentioned, the actual equipment in the aircraft is, every single piece has to be certified up in Canada for that purpose. And, the manufacturers that make the gear obviously make them to certain standards, but in the US, that portion of it is a lot less regulated. It's very similar as far as what's required to be able to do the type of flying, but there's under the public use exemption, which we have in the U.S., is a little bit more liberal. Essentially, any public safety type of an operation is able to operate under that regulation that says that some of those things don't necessarily need to be followed. It's in the best interest of the agencies to follow the I think what I would say are the industry standards. But as Rob said, you don't have to, under certain public use exemptions, either have like a certification in the U.S., which is CFR Part 133. You can actually be exempt from certain things, like actually holding the certificate if you're a public safety agency. So a little bit more liberal in the U.S.
I was going to say, I can't speak to the details of the Australian situation, but I'm sure it's going to be up there with one of the most restrictive in the world in terms of all those requirements as well.
Yeah, totally. From my perspective, from my understanding of it, and this was quite a while ago now, things have changed a little bit since I was there, but I would say it's somewhere between where we're at in Canada and where the US is at. And I think that's a good middle ground. I think perhaps in times Canada can be a little too restrictive in the wrong areas and it isn't really a common sense approach. And at times I think the US, with some of the lack of restrictions, it's where we see some of the accidents occurring and people, like I know you mentioned earlier, Mick, about people just going and grabbing some gear and going to work. And to be honest, that's happening out there, not often and certainly more than we would like to see happening though. And those are the guys that may potentially find themselves having problems, is the ones that do just go out there, grab the gear and think it's just a matter of going to work and not really having a true understanding of how that equipment works together and how to use it best to achieve the goal that they're trying to achieve.
Any input from EASA land? How does the European side look?
I think from what I understand, again, I've never worked in Europe, but I've certainly spoken to quite a few people over there. And I think it's a bit of a piecemeal at times. It's kind of all over the place. I think at times you'll see a lot of documentation, a lot of regulation come out of Europe saying very, very restrictive, and this is what you must do and this is what you have to do. And then you'll also see some fairly liberal ways of doing business as well. You know, guys are just literally tying ropes to the end of hoist hooks and extending their hoist lines by a couple of 100 feet or meters. And yeah, there's some really interesting stuff going on over there. And I can't speak specifically to the legislation, but I think they're working really hard. It seems that there's a lot of people working really hard on trying to get that dialed in, and particularly with certification for the actual crew members, guys like the hoist operators in the back that up until now, I mean, really haven't been really all that well regulated in terms of their training and experience. So I think they're doing some really good things, but I think it sounds like from what I've heard that there are still some challenges as well.
All right, well, let's get into the guts of it then. So we've got a couple of points there in terms of just a rough outline of giving someone who's new to slinging a intro of the key points. So yeah, how you guys want to tag team as we go through that? But let's start with some of the aircraft side of things, the safety precautions for the aircraft.
Yes, I think we can kind of give you an insight from both the pilot's perspective and then from the hoist operator or the rescuer's perspective in the back. And Rob can definitely do a good job at that. You know, for the pilots out there, anybody that's never done any type of vertical reference flying or long line or hoist type operations, it's there's a lot that goes into it, and there's quite a bit of actual communication and CRM between the crew, both pilots. If it's a dual pilot operation, some folks do hoist operation single pilot, but there's a lot of communication between the hoist operator and the actual pilot in command. As I said, these types of things are very slow and methodical. We do it's a fairly quick, but it's a very thorough briefing prior to actually starting the hoist. And some of the things that we cover in that briefing include, basically like the wind dynamics, the direction and speed, the target approach and departure to the area. What type of hoist are we going to do? Are we going to do either a static or a dynamic? And for people new to the industry, static is essentially when you fly over the top of the target and stop the helicopter and hover and then lower the cable down. And then likewise when you bring it back up. And then dynamic is when you're actually flying fairly slow, but flying to the target in forward flight and lowering or raising the cable in flight. Kind of some different benefits and for each of those techniques that we won't get into right now. But essentially, we do a thorough briefing of what we're going to do, and then any potential emergencies, what we could expect, and then what the crew is going to do to respond to those emergencies. And then essentially another thing that's really important is we have everybody identify their cable cut switch in the event of some of those emergencies in case the cable has to be cut. So pretty thorough checklist that's run. And once you've done this enough, it goes fairly quickly. And then as far as the pilot goes, it's really flying a nice, stable, slow, ideally flat approach to over the top of the target. And once you're over the top of it on station, just prior to getting there, the hoist operator is going to have to pick up what we call the con, or giving you conning commands, because eventually you're going to be over the top of it. You won't be able to see it. So once you lose sight of the target, you announce that to the hoist operator, and then the hoist operator will call you in over the target and eventually have you stop. Occasionally make minor adjustments, and then once you're in position, they will commence the hoist. And for the pilot, the biggest thing is having good reference points, daytime and then especially at night on goggles. So it's common for us during that briefing. One of those options or things that we talk about is the reference points for the pilot. And if they're not good, we make sure that we tell the hoist operator, hey, I do have a reference point, but it's fairly open. Maybe we're going to be a little bit higher than normal. So I need you to let me know sooner if the aircraft is moving, because I may not pick up on it as quickly as I normally would if I was right next to something, that was maybe 100 feet away, a nice rock outcropping or a tree top or something that would give you a very good indication of small movements that the helicopter is making. So on the pilot side, really biggest thing once you get in there is just having a reference point and then using that to make the helicopter stay as stable as possible so that the hoist can be conducted. And then obviously flying very smoothly helps considerably, especially when you're making very small adjustments once you get in close to the target. And that's essentially kind of the pilot's point of view from just a single hoist stop.
And Dave, do you have any tips in terms of, like task loading or detachment? Because often, especially if you're the pilot in command flying, you are busy hovering, you're busy monitoring what's happening in the background, but you still have to be the pilot in command in terms of the aircraft safety. Because often, as you get conned in, especially when you're overhead, the air crewman takes over a huge amount of responsibility for the aircraft operations. But do you have any approaches, or when you're sitting there in the hover, how do you sort of just keep a little bit of spare capacity to to keep doing that pilot command type things?
Yeah, it's a good point. Essentially, the pilot command is in charge of the aircraft and the entire operation. So you do have that added responsibility on your shoulders. So really, I think a lot of that initially comes down to the decision making. It's kind of funny. We joke about it sometimes with the rescuers, but those folks, they're a lot of times very focused on, hey, we need to get in there. We need to get this person out. They're injured. They're critical. So not that they would, be willing to take extra risk, but that's the focus of their job. Their job is to get in there and treat people and get them out. And occasionally, we'll always have these discussions during these briefings, but it's common for the pilot to finally just kind of get everybody's input and then say, hey, I'm going to call it. We're not going to be able to do this, or we're not going to be able to fly necessarily deep into a canyon and put people in. We might have to put them just outside of the canyon, and they're going to have to hike a mile to get to the victim. So the final decision always comes to the pilot. And as far as trying to make sure you keep that same, that mindset and don't get overloaded because you're actually holding the hoist, or holding the hover while the hoist is going on. Really, you have to rely on the crew. And there's a huge benefit to having a second pilot up there, especially one that's qualified to hoist, because they're not as task saturated and they can help monitor, systems and, call out power settings and just basically monitor the operation and give the PIC the information that they need to make some of those decisions, up to and including, potentially even just aborting the hoist, bringing the people back up and going around and trying it again. So really it all comes down to good CRM, I would say.
Okay, Robin, in terms of setting the aircraft up in the back of the aircraft, what are some of the things?
Yeah, for sure. Yeah, definitely. I think, the aircraft safety procedure side of things, for me as a rear crew member, that starts the minute we walk out to the aircraft. I just like a flight attendant on the local Qantas flight or whatever, I'm kind of responsible for everything that happens behind the pilot seat. So I've got crew that may be trained, that may be untrained if they're people being rescued or other like non-air crew rated passengers. So I need to make sure that the absolute basics are covered, right down to seatbelts and fire extinguishers and communications and that sort of stuff. And that's kind of where it all begins from my side of things. We need to make sure that all the people in the back have received a good briefing and really understand what their role is, if they have a role, and how they're going to evacuate if we have a problem. Ultimately, that kind of does come down to me if we do have a problem to get those people out and keep them safe and that sort of thing. So we want to make sure we're giving them a really good briefing from a passenger side of things, and then we need to be able to keep control of that cabin throughout whatever we're doing as well, the mission, whatever might come up as we make our way along it. I think a lot of people underestimate how important the synergy and the relationship between the pilot and the hoist operator can be. I think, to kind of shoot ourselves in the foot here, hoisting is actually fairly easy until something goes outside of the standard, if you will. Really, a lot of people think it's just hoist goes up, hoist goes down, and that's the end of it. But to be able to understand that when we have a crosswind and you've got a left skid low aircraft, that it does tend to, lean more into that wind, you then lose controllability, you're more likely to run out of cyclic things, little things like that you don't think about. And these are all the stuff that's going on between the pilot and the hoist operator. And the more that the hoist operator in the back can understand when we talk about single engine performance or our breakaway or our escape route from the scene or anything like that, the more understanding the hoist operator has of how the aircraft functions, the actual safety procedures in the event of a malfunction or a problem, it just takes a lot of load away from the pilot. The last thing the pilot wants to be doing, and I'm sure Dave would agree, is worrying about whether his guy in the back really truly understands the procedures or whether he's just read it out of the manual and is following the book. So having a deep understanding is really important, I think, from the safety procedure side of things. And then again, we need to know between the pilot and the hoist operator what each other is going to do in the event that we do have a problem with something, which I think we'll get into in a little bit with the specific emergencies as well.
All right, well, how about you talk us through if that works in this method, and Rob, in terms of Dave was talking about you're coming in on approach, and at some point the pilot's going to say they're losing visual, and the air crewman in the back is going to start talking the aircraft in. Can you just give us just a walkthrough of how from there to lowering the sling to bring the sling back up? What are the sort of key steps that you go through?
Yeah, I think a lot of it is obviously control. You need to be controlling the height of the aircraft as it went on its way in. So you need to make sure that the aircraft is going to be well clear of obstructions. We're above the canopy, we're above any hazards that we're flying over, but not so low that we're going to blow trees down or blow debris out of trees and things like that. So it's managing a height. We try and come in fairly flat with our altitude. We don't want to try and be climbing or descending too much as we're approaching a target. It's one extra thing that the pilot has to be dealing with that we don't necessarily have to be. There will obviously be situations that are outside of that, but I'm calling his heights as he comes in, whether his height's good. We're going to be controlling speed, so either speed's going to be good, you can increase your speed if we're coming in really slowly, or most often it's you need to reduce your speed because we're coming in too fast. A lot of guys, especially early on when they're first in training or had just jumped into a new program, will usually approach way too fast, and they end up getting task saturated as the hoist operator in the back. And we're calling numbers as you approach, and we always say, it's kind of an arbitrary number, really. You start back, you give yourself enough time, so you might start at a 100 call. And as long as 50 is halfway to the target, it doesn't matter if you're a kilometer away or you're 5 meters away. As long as the numbers match your cadence and the way that you're using those words to call the pilot in, you're basically painting a picture for the pilot that he can't see. So, it's forward 100, forward 50, forward 30, forward 20. And as you're calling those numbers, and it gets right down to 3, 2, 1, and you're talking about feet to inches at that point. And we're making corrections to the line on the way in as soon as that pilot loses the sight of the target. So we're correcting him early, whether it be left or right on that line, because it's much, much easier to, instead of going forward 100 and then right 100, we can go forward and right 150, trigonometry, and you end up, roughly speaking, where you need to be. But you're not making big movements and unsettling the load. You want to make small corrections all the way in and really try and be ahead of the game. And that just comes down to practice and doing quite a bit of it rather than trying to make big movements to correct things late.
Okay, and once we're overhead, well, actually, before we do that, how many hoists these days are internal versus external? You just want to talk about, you've got V&E for cracking the door open and how that sort of interaction works on approach in terms of airspeed.
Yeah, for sure. So I think to answer your original question, I think there are still some internal hoists out there, especially older legacy machines. In the US, a lot of guys are still running old left military Hueys and variants of Bell Medium, and they do have a lot of internal hoists. But the way that it's going is really starting to drive down the road of the external hoist. There is a couple of manufacturers, but most of them are still providing an external option for the aircraft. So we are limited, like you say, by airspeed for opening doors. Really, for us, there's no huge benefit in opening the doors anywhere above 60 knots. It just becomes loud and windy, and we want to try and reduce that speed down, generally below 60 knots, before we can really be deploying any cable anyway. So we usually use 60 knots as our number, and then we can start going to work beyond that.
There's something I didn't pick up for ages, but often, so you've got the the sling down, and the sling, or the strop is reasonably light on the end of this cable, and it's going to be affected by rotor wash. But what I picked up later and talking to a couple of guys is when they'd say, come left 1 or come left 2, it wasn't so much they were trying to move the aircraft. They were trying just to get a slight downwash difference to actually move the sling across to where they wanted the sling to go. So can you just talk about how you sort of steer the strop on the way down?
Yeah, you certainly can do, for sure. I mean, it's a bit of an art form, for sure. And every aircraft is different. So it really is becoming familiar with the aircraft. And that's just why it's so important to have guys that have either seen different aircraft or have a wide range of skill set to really draw upon when you need it. But yeah, you can certainly, you're flying the hook. You're not necessarily flying the aircraft. If you are out hoisting to a boat that's trucking along at 20 knots and you've got a headwind, the hook may be 20, 30 feet behind the aircraft. So you're not necessarily flying the aircraft to where it needs to be. You're effectively flying the hook. And Dave spoke a little earlier about the dynamic hoisting, and I think we'll probably get into that a little later on as well. But just understanding where that rotor wash is, and ideally you want to try and keep the hook or the load away from that rotor wash in the first place. It's a prevention rather than cure type situation. But yeah, I mean, you'll notice particularly when you're low and that downwash from the aircraft is making it all the way to the ground and is still quite significant when it makes it to the ground, you'll actually see a bit of a bubble in the air. You picture a column of rotor wash coming directly down and then spreading out in all directions when it gets to the ground. And you'll see the hook come down. It's nice and light if you don't have any weight or something that catches a lot of airflow on the bottom of it. And then it will actually push out to the side. And you have to kind of maneuver the aircraft around a little bit. It's kind of hard to explain just with your voice, but you do have to maneuver the aircraft around a little bit to either try and get it to catch a different spot, or sometimes it's just a patience thing. You just actually have to wait and let it settle itself out in its own time. No amount of movement's really going to help too much.
Is now a good point to talk about like control checks and the actual pickup and things like that, or should we talk about that later on?
No, we certainly can if that's what we want to talk about, for sure. Yeah, do you want me to get straight into that?
Yeah, if you just keep walking through, because again, I'm thinking someone who's flying R-44s has only ever seen pictures of a rescue helicopter with a hoist down. Will have never ever heard the kind of patter or the process that you go through. So if we want to take it, we've pulled up to the hover. We're over the top. We're dropping the hoist down to pick up the survivor. What are we hearing, and what are you doing in the back?
Yeah, go ahead, Dave.
Yeah, so as far as like the actual kind of the communication between the pilot and hoist operator, like Rob had said, it's kind of a constant banter, and then once we get over the top of the target, they'll make minor adjustments, very fine adjustments, and then they'll confirm that we're basically over the target and we're stable. The biggest thing is you want to make sure, like you said, that you have the power and the control ability to do that before you actually commit to starting the hoist, particularly with the dynamic hoisting. And there's been a little bit of it's interesting. There's been debates over the years as to, what's better between the two techniques. And again, we can talk about that, after this, but essentially the biggest thing that we preach, especially for the pilots, is that you have to make sure you have the power and the control ability before you go into an area to start the hoist. You also want to 100% make sure that you have a way to execute a go around. And there's times at lower altitudes and good conditions and powerful helicopters where you just know that there's not going to be any issues of power. You're not going to have any control ability. And for folks that don't do this type of flying, when we talk about that, it's not only being able to keep the aircraft nice and stable over the top of a target, but in many cases, it's actually running out of tail rotor authority. And my own experience flying Hueys that, we've done altitudes well over in the 10, 11,000 foot range for years. And the limitations in the Huey typically wasn't power. It was actually running out of left pedal for tail rotor authority, because the engine could produce the power. The tail rotor eventually just reaches a point where it can't keep up. So you want to know that before you go in there and commit to actually putting a live person on the hook. So what typically the pilots will do is either do a dry run or a rehearsal. And to do that, what we normally do is set up in that vicinity, in the same direction that the aircraft is going to be pointed. And that's very critical because the wind direction has to be the same. So it doesn't do you any good to do that power and controllability check pointed into the wind and then go in over the target and have the nose pointed 30 degrees to the right, because the power and controllability will be different. So you need to confirm that before you commit to the hoist. Occasionally, if the conditions are a little gusty or you don't have an excessive margin for power and controllability, we will do a static hoist. We'll get over the top of the target. The hoist operator will con you over there, and then the pilot will want to actually just wait there momentarily and ensure that, okay, I do have the power required, I do have the pedal, or I do have the ability to keep us directly over the target, and then commence the hoist. And there's a lot of communication between the hoist operator and the pilot that goes in prior to starting that approach and then getting over the top. And then as far as the actual communication from the hoist operator, I'll let Rob speak on that. But again, the whole process has a lot of CRM. So Rob, you want to touch on that?
Yeah, for sure. So I think, like as Mick's alluded to, and as we said earlier, it's almost a constant flow of information. Once the pilot loses sight of that target, really, you have to keep him on top of it. And newer guys will get a reminder fairly quickly that they're not, because they'll hear from the front end, hey, what's going on back there? That's the cue that you're probably not speaking enough. But yeah, as soon as we arrive on site overhead and we're actually going to start the hoist, I absolutely want to be letting the pilot know once the hook is below the skid. Now we're interested in entering a critical kind of phase of the operation. We also really try and let the pilot know once we are what we would call committed. So the hoist cable and hook has actually entered the obstructions. We're into the canopy of the trees. We're below the cliff level. We're, in amongst masts on boats, that sort of thing. So we want the pilot to know, hey, if we do have a problem right now, we need to stay here if at all possible. Either that or we're going to cut the cable. So that's a really critical one to let them know as well, is once we're actually into those obstructions with the hoist or the load. And then again, once they're approaching the ground, if it's an empty hook, we're going to let them know, hey, hooks almost at the ground, hooks approaching the deck, 3, 2, 1, hooks in the deck. Once the guys on the ground that have got the hook in hand, that's another really, really critical one, because again, if they're working with the hook, they might be hooked up, they might not be hooked up. They're right in that really critical phase for us. And what we don't want to do is have a problem with the aircraft, think we're clear to start flying away because we've got a problem, and there's a guy attached to the end of it at that point. So that's a really critical phase for us. We're training our guys on the ground to be really, really quick with those connections so that we're not sitting in that no man's land for too long. And then we'll make corrections to the position as we're in that spot as well. If we've drifted a little bit, we want to make sure we're dead center over the target when we're picking it up, because down in a tight hole in the trees or on the aft deck of a ship or something like that, there really is very limited space to work. And the last thing we want to do is swing a guy into an obstruction, either hurt him or get the cable snagged up in something. And then, as Dave spoke about earlier, as we start to take that weight with either the aircraft or the hoist, we have both options. If it is a fairly technical spot and we're concerned about controllability, I mean, we spoke about it as well. You think about the guys that are out there flying around in R22s and those sort of size machines, Mick, in your G2 as well. You might only be carrying a payload of 400, 500, 600 pounds or, 200, 300 kilos, whereas we have the ability with the hoist to put 600 pounds or almost 300 kilograms on the hoist hook, and it's right at the very, very outer edge of the aircraft. So it effect center of gravity is massive. We're basically picking up the entire payload of a training aircraft on the outside of the aircraft of ours. So it can affect controllability quite a bit, and we want to make sure that when we take that load that we are still within our limits for cyclic and things like that. So we'll take the load at that point. Either the aircraft will just really slowly pick up and we can ask the pilot, hey, are you happy to continue? If he's the one taking the load, more often than not, we know in advance that we're going to be okay, and we're happy for the hoist just to take the load itself. It means the pilot can maintain a better hover reference. We don't need to be changing that position. He has to reset his, recalibrate his hover references. So we kind of stay in that one position and let the hoist do the pick. And then once that load's actually fully on the cable, we'll just pause or slowly retract very, very briefly and just confirm with the pilot again that his power and controllability are good. And then at that point, it's basically a matter of keeping the aircraft positioned over target using voice commands and getting those guys up and clear of the canopy again as quickly as possible. Because then again, we talked about committed going into those obstructions, into those trees. The pilot is kind of hanging on that information next is, hey, when are we clear of those obstructions? Because if I have an engine failure or something else goes wrong, at that point, the pilot's going to be comfortable knowing that if we need to, we can depart the scene right away.
Excellent. I guess that comes back to that dynamic approach as well, because obviously, you want to minimise the time you're sitting in the hover. So you, as a pilot, you're sort of sitting waiting for that clearance to actually start moving and getting some airflow going again.
Totally, absolutely. And I mean, it's not that the aircraft can't necessarily do it. It's just that you're working it harder than it needs to be. And, we'll get into a little bit of the swing and the spin and managing those risks later on. But we spoke a little bit about the downwash and the way it affects the empty hook. Even as you're in the hover, that downwash beneath you, that affects the load. It affects your stretcher if you're hoisting a litter or a stretcher or a basket or something. And by actually making an approach with a little bit of forward airspeed, you picture the rotor wash column, instead of being vertically down beneath you, it actually starts to rotate and kind of be directed more aft behind you. Whereas the load, because it's a heavy weighted object, will actually still hang directly beneath the aircraft or close to, and it's clear of that rotor wash and it's just totally unaffected by it. So even if we're going into a target that's going to be a fairly restricted hole in the trees or something like that, we'll actually approach the target in that dynamic profile as much as we can with the load beneath the aircraft. We'll get overhead target, and we've already paid out, that 30, 50 feet of cable to get them kind of clear of that really severe rotor wash zone. And then once we arrive on target, they're clear of that. The rotor wash catches up to us again at that point, but it's much less severe because the load is already below and clear of that really, really turbulent air. And then we can continue down into the trees with less impact from rotor wash, which is helpful for everyone.
The next point we've got there is fall protection and restraint requirements. So we want to tackle that one?
Yeah, I can keep going here for sure if we're talking about that. And I think the big thing here is every single aircraft is different. And, even within, you go to Airbus tomorrow and you go buy 2 brand new H145s, and they're going to come delivered more than likely with different cabin configurations and different hard points and things like that. So keeping it simple is really, really important. And you do want to have lots of connection points for your guys to keep themselves safe inside the cabin of the aircraft. But at the same time, you need to provide enough redundancy in the system that you're not relying on necessarily one point for the whole aircraft to keep guys restrained and safe. If you've got multiple guys, you want multiple hard points. If you're moving around the cabin, having options within that cabin is nice. And you want to keep a nice, clean workspace. Anyone that works in rope access or anything like that knows well that it's all about housekeeping. And what you don't want to do is have lanyards across an open doorway and then guys are tripping or stepping over, hazards to get in and out of the aircraft. That to us is a cabin that hasn't really been thought out all that well from a rigging standpoint. So we spend a lot of time in the early stages. If we have a client who's looking to equip an aircraft, we spend a lot of time in the early stages just making sure that it's rigged as good as it can be. And I'm a bit of an OCD type guy, so I try and get stuff down to the nth degree of perfection. But there is certainly some things you want to do with regard to load sharing and some redundancy and stuff like that can make your life much, much easier down the road for sure.
And I guess what we're talking there, though, the primary thing is you're either in a seatbelt or you're hooked onto the floor or the roof or something like that. So at any particular time, you've always got a restraint and you're never sort of floating between the two.
Correct. Yeah, absolutely. And then like that is a major issue. If you have someone in the aircraft with the door open that isn't restrained by any means, we have a really serious problem at that point. So one, like you alluded to there, one method of restraint is the bare minimum. And then as much as possible, we actually try and, especially if you're going to be transitioning from one position in the aircraft to another, for example, from your seat to the doorway of the aircraft to the hoist hook to be hoisted, we want to, as much as possible, keep guys on multiple forms of restraint and on one for as little as possible of that time. So you're on your seatbelt and you're on some kind of retractable lanyard some kind of lanyard inside the aircraft. You're on both together. Then you undo your seatbelt. Then you move to the doorway. Then we put you on the hoist hooks. You're on two again while we make that transition outside of the cabin. So again, it's just redundancy in those critical phases.
And Dave, in terms of moving into SAR mission planning, what are how do you guys set up the scenarios to sort of practice that decision making as you go through that?
Yeah, so as far as setting up scenarios, we commonly will tailor one to the needs of our customer in the area that they operate and the type of rescue that they would typically be expected to conduct. But a lot of the things initially when you receive information for a type of a call or a job where you're going to actually launch and go try to recover somebody, a lot of the considerations aren't that much different initially as if you just jumped in an R-22 and went on a normal flight. Obviously, you want to consider weight and balance, fuel considerations for endurance. The weather is a big one. So that stuff falls, for the most part, the same. Some of the weight and balance can get a little bit tricky, though, because you need to take into consideration, like Rob said earlier, if you're going to pick up somebody that's fairly heavy, and especially if you're going to take a rescuer and a victim at the same time, some aircraft have a lot more issues with lateral CG. So you really don't want to find that out when you're in the middle of the hoist. You run out of left or right cyclic, the aircraft is drifting and you can't stop it. So that's a big part of it. Another big thing is just the mission type versus the crew experience. We really hammer that home to evaluate what is it that we're being asked to do and are we qualified to do it. So a lot of times that's exactly where you start before you even get to the mission planning, because if you don't have the experience to do it or you can't call on a crew that does have the experience, then you need to either not go or you need to at least maybe look at some other options before you launch. In addition to kind of those factors, once you know what you're going to do, what you're going to be expected to do, you're qualified to do it. You've kind of gone through all the weight and balance, performance, fuel, weather, and all those things. We strongly recommend doing some sort of a risk assessment prior to launch. And there's a lot of templates out there that can be provided from various sources on different websites and organizations. But essentially, you should do some sort of a pre-flight risk assessment. And just quickly to run through how that works, you break up the flight into areas of risk. So, for an example, one would be human factors. And a common one with that is if, say, Mick, you worked an 8-hour shift, just normally flying, and then you're on call, and then you got called back 4 or 5 hours later into the middle of your sleep cycle. So that's going to essentially make the operation a little bit more risky. It doesn't mean you shouldn't do it, but fatigue is going to be something that has to be considered. So there's areas in that risk assessment that will be assigned a score. The riskier it is, the higher the score or the higher the number. And you essentially add up that score, and then it'll put you into a category of, just for simplistic terms, it's either going to be green where you would go, yellow to where it needs some extra consideration or approval, or red to where you won't go unless you can mitigate some of the additional risk. It could be fatigue. It could be, the weather, thunderstorms, low ceilings, poor visibility. They could be the locations at a higher altitude than you normally operate. So things of that nature. And then once you go through that process, and it doesn't take long if you've established it, then the last thing that we really preach is just doing operational risk management once you take off. A lot of times I think we get wrapped into just thinking, okay, we've done our due diligence, we've assessed the risk, and then we launch, and then we don't think about it anymore after that. Well, it's essentially something that should be kind of a continuous process. So if you get into the area of operation and some things have changed, you need to always be constantly reevaluating the risk of what you're doing. So if you get there and maybe you were told the victim was 120 pounds and then it turns out they're 300 pounds, that changes everything. So you need to reevaluate that. And it doesn't mean, again, that you can't do it, but you might change what you do. And you have to have a quick discussion amongst the crew as to how you're going to accomplish that safely. And that process continues all the way back until the mission is complete.
Again, I'm just conscious of the time there, so I'm going to keep rolling through our points here and cover as much as you can. So I won't dive any deeper on that, but there is I don't mean to brush over that lightly because there's heaps of stuff there. But let's roll into emergency procedures then. What are some of the things that can go wrong in doing a hoist?
Yeah, so Rob, you want to maybe talk about? Yeah, go ahead, talk about that.
Yeah. I mean, we're really cognizant, I think, and again, this is one of those things where if you set yourself up for success from the beginning, you reduce a lot of that risk by, as Dave said, getting yourself into a position where you know the variables, you know what might happen, and you have a plan for that problem. Things that you don't expect to happen can quickly become an emergency, but if you brief them and plan for them, either the severity of the situation is drastically reduced, or they're not actually an emergency at all if you know what the plan is at any point during that. So we have a bit of a list here. I mean, the obvious one that everyone kind of thinks of first is obviously an engine failure, and in a single engine aircraft, that's a fairly serious situation. At any point, really, you are going to go to ground, and you're going to have to find a way to get there. It's basically a damage control type situation. If we've got an empty hook beneath it and no one's on the line, then obviously we're just going to cut the cable and just the pilot's going to fly the aircraft. He's going to try and get it to the ground via rudder rotation or whatever option he's got available to him as best that he can. Once we get up into twin engine aircraft, obviously the options become much, much greater. If we have that one engine in operative capability, then the answer is fairly simple. We do nothing. We just continue doing what we're doing. And we either get the guy to the ground or we get him clear of those obstructions as quickly as possible. And the pilot does what he does. It's just basically an aircraft at that point that suffered an engine failure, and we fly away. We have that OEI capability. If we don't, we might have the ability to, again, kind of like the single engine thing, either fly away immediately if the guy is not in amongst obstructions, or if we've got enough time just to get the guy to the ground or get him up and clear of those obstructions, then we can commence a flyaway operation. And for the hoist operator in the back and the pilot, it's really key that both of us know exactly what that plan is going to look like beforehand, so we can plan appropriately. For us, really, that really is truly one of the only emergency procedures. Things like tail rotor failures and things like that we can get right into, but you would have had to have usually run into something, or something would have usually happened in the hoist to get yourself into that position. So I think to stick with more of the hoist-related emergency procedures, there's been lots of online chat lately about things like spinning and taglines and stuff like that. But ultimately, again, prevention is better than cure. Using equipment like a tagline appropriately, using dynamic hoisting profiles when appropriate, can mitigate a lot of those spin issues.
So Rob, again, someone coming with no background, can you just walk through what a tagline is and what it does?
Yeah, absolutely. So a tagline is just basically a rope that's been, gets stored in a bag and is deployed with either a stretcher or a basket or whatever rescue device you're using. Usually not used too much for just people on the ground. We can, but it's less likely to be used for that purpose. It's mostly as a spin reduction tool and just a controllability thing. So the rope is connected to the rescue device, whether it be a stretcher or a basket or whatever, and Yeah, as long as there is some angle in that tagline and it's connected between the rescue device and a rescue attendant on the ground as it's being raised or lowered, then that rescue attendant on the ground can maintain some tension using that rope to the rescue device and keep control of it. It'll stop it from spinning. It'll stop it from swinging around too much. And we actually have the ability where we can't get the aircraft directly overhead necessarily, so we can slowly pick the load up off the ground. And as it returns to center to plumb itself under the aircraft, we can use that tagline to slowly pay out some rope and slowly move that piece of rescue equipment underneath the aircraft in a controlled fashion rather than just letting it swing. So yeah, it's a very, very useful tool when used properly. But again, we don't have time, I'm sure, to get into everything today, but there's a whole podcast just on taglines. But yeah, there's certainly a right way and a wrong way to use them. And as we've seen online, I'm sure we can get ourselves into trouble fairly quickly if not used correctly.
I always used to like the part of the brief for back on engine phase in the Huey, and that is obviously we'll call cut, and we'll cut the load at a height to minimise injury to the survivors. But then I always used to feel, for the guys in the back, because obviously in the front you're sitting in a chair with all your crash resorption and everything. For the guys in the back, you've only got a couple of seconds to try and brace yourself best as you can for the touchdown.
Yeah, it's less than ideal for sure. And, that is really one of the hardest conversations that we have during the training is there just has to be a bit of a greatest good for greatest need type mentality. Sometimes you can be in positions, especially in the rescue world, where, you may have to be faced with a decision, and we try and mitigate that as much as we absolutely can. And, for a lot of operations, we just simply wouldn't put ourselves in that position to start with. But it's really, really important for the guys to know exactly what they're in for, because, there can be some unpleasant situations depending on what you're getting yourself into.
Okay, what's the next sort of thing in terms of what can go wrong?
Yeah, so I think in terms of the spinning, just to finish up on that one, if it's happened and it's something you've got and you have to deal with that, at that point, a lot of the time, just getting some airspeed, so actually flying immediately, and it shouldn't be an expedite. It shouldn't be a delayed reaction. As soon as you can, you want to get that load up, clear the obstructions, and commence forward flight, and then everything's going to stabilize out quickly. And so that's the preference for sure. And if you don't have the ability to do that, and you really need to take a good hard look at how you're going to accomplish that mission safely. Again, that's a long conversation, but there are a few ways to definitely mitigate that risk. And then in terms of what we would call malfunctions with the aircraft, if the aircraft's flying normally, if there's no actual problems with the aircraft, a lot of the other things that we do is we don't consider them emergencies because there is no real rush. There's no life and death situation. We rarely would see, but it can happen where the hoist cable actually gets snagged up in something, so it'll get tangled in something. A lot of the time, I think this would be seen with an empty hook. When there's loaded on it and the cable's tight under tension, it's less likely to wrap around things, and you've got a smart, intelligent rescue specialist on the bottom of the line that can keep yourself clear of those obstructions as best they can. So more often than not, I think you're likely to see this when you've got an empty hook. But again, if the aircraft is able to maintain a position, you can either work through that situation to try and free it, or you do have the ability to cut the cable. But again, there's less likely that someone's going to be on the hook at that time. And then really the other ones, you can either have a runaway of the hoist, where it's basically doing something that you don't expect it to be doing, whether it's paying out cable or bringing in cable. We control that a little bit. We can do what's called a controllability check on the hoist. So as it's approaching the skid or as it's approaching the ground, we'll just stop quickly in advance, 10, 15 feet, something like that. And if you think it's going to be a concern or you don't want to be putting that person down hard into some technical terrain, you can do that check in advance. And then if you do find that you have a problem, you have time before touchdown to actually remove power, to isolate that power from the hoist so that the hoist stops. And then it becomes, you're effectively a long line operation at that point. You still have complete control of the load in the aircraft. You just don't have control of the hoist anymore. So you may need to actually climb the aircraft up and out of that spot and transition to a nice clear area to get the person down in. But for us, we have the ability to move the aircraft. We're under control. No one's hurt. Nothing's broken. So other than the hoist, so we can make that work. It's not the end of the world. And likewise with a stoppage. So if the hoist just stops due to a snagged cable inside the drum of the hoist, the actual mechanism of the hoist is miswrapped, we call it, or some kind of other malfunction has happened inside the hoist unit itself, inside the mechanism, again, we basically won't try and fix too much of that in flight. We already have one problem, so we don't want to make it worse by trying to do troubleshooting too much, unless it's something really obvious, in which case it's kind of the same as the runaway in that we just revert back to a short haul or a long line type operation where we just turn the power off to the hoist, totally isolate it, and we'll transition that person down to a clear open area and do the troubleshooting without a human on the end of it.
We haven't talked about...
the main one.
I was going to say, we've talked about cutting, but we haven't actually talked about how the cable gets cut. So, Dave, do you want to talk about what's in the aircraft in terms of, electrics and how the cable actually gets cut?
Yeah, so there's essentially, there's two methods to cut the cable, and the primary means would be with, there's a little cartridge in there. Essentially, it's a little explosive cartridge that would fire a cutting device internally inside of the hoist. And depending on the aircraft, there may be more than one actual switch to fire that device. And the hoist operator typically has one on the hoist or on the pendant or the hand controller. That's pretty common for, in larger helicopters, both the pilot and the co-pilot to have individual switches to fire that cable cutting device. It's also common, like in the Huey, for example, there was just one on the center console, and it's a switch with a piece of safety wire over it. So basically, it's an electrical, the switch that fires a small, similar to like a primer type of a very small explosive type device that drives a blade into the cable and actually shears it. The other method would be just manually with a pair of either something that looks similar to a set of bolt cutters, or there's also some pretty interesting aftermarket devices that allow the hoist operator to actually reach out with something that looks similar to like a small hand axe and then pull towards them and shear the cable that way. So really it comes down to either internally within the aircraft or manually with a set of cutting type devices from the hoist operator in the back.
Rob, have you ever actually physically tried to cut the cable on the ground and things like that? Like, how hard is it to cut the cable?
I think, Dave, the two manual, we've never actually cut one obviously electronically using the explosive squib, but thank God. But yeah, we've played around a lot with the manual cable cutting. I think anyone that operates a hoist should get an old piece of cable and use their cable cutting device. Dave mentioned two options. There's the style that kind of looks like a set of bolt cutters, and like you said, that's really a two-handed thing, and that cable has to go within the jaws of those bolt cutters, which in flight is a real challenge, especially if you've encountered some kind of malfunction or problem. Really, I wouldn't want to be in a position where I have to do that. So the second option is, I believe it's by a company called Zephyr, and they make a single-handed device, which basically it's a big long pole with a hook on the end of it. And just by making a sweeping horizontal motion, you can actually catch that cable, and it collects the cable from a much wider area and kind of funnels it into that cutting jaw. And then once it's in that position, you can kind of rest the end of the pole in against your rib cage or in your hips and pull back single-handedly on one handle, and it'll actually cut the cable using a mechanical advantage system. And yeah, we've played around with both options, and we have the latter in our aircraft because of the ease of use compared to the manual two-handed bolt cutter mechanism. And that's much better to use that mechanism if you have a problem with the hoist or a snagged cable or something like that. To cut the cable manually is to fix that after the fact. It's just a replacement cable as long as there's no other issues. If it's just a snagged cable or a damaged cable, then you can just cut it manually, and the rectifying action is just to replace the cable. Whereas if you fire that explosive squib, that hoist is unserviceable. It's coming off the aircraft. It's going back to the manufacturer, and you're looking at tens and thousands of dollars for repair. So you have a preference for sure, as long as there's no safety issues surrounding cutting the cable manually. If it's something that has to happen quickly, then electronically is always the go. We're not going to compromise safety. But there are cases where manually is certainly the preferred option.
Is there any equipment out there where you can carry a second hook and reconnect it on the wire after it's been cut, or that's it? Once that wire's done, it's done.
So there is a device as well. It's called a quick splice. There's a couple of different versions of that piece of equipment, but yeah, they basically involve providing you have to have cut the cable manually. If you cut it electrically using that squib, it's done. The hoist is toast. There basically is no that particular hoist will not be doing anything again until it's repaired. But yeah, we do have the ability to cut the cable manually and then attach what's known as a quick splice to the end of that cable. It is effectively a replacement hook, and there are a couple of really, really slick designs for that out now that
But again, you really shouldn't be going out and doing hoisting operations without one of those sitting in your cabin somewhere. They're a few $100, and it's when you need it, it'll be the best money you've ever spent for sure. They're the same hook that you have on the regular hoist before you had to cut it, and it takes 10 seconds to attach, and you can basically use the hoist as before. Obviously, you've shortened the cable by potentially a significant amount, so you need to be aware that you only have a limited amount of cable left on the hoist to use. And then some of those functions, the hoist basically knows how much cable is beneath it. It has a payout meterage, and you know how much cable is paid out at any point. So if you cut the cable at half of its length, it still thinks that the entire length of the cable is deployed, even though half of it is actually there. So you're going to see that hook arrive at the aircraft while the number is still reading higher than what it is, and you don't have the ability to slow down the speed of the hoist as much, or you don't have the ability to slow down the speed of the hoist as it approaches the skid automatically, like the hoist would normally do. It automatically normally slows down as the hook approaches the skid. So you have to be really, really cognizant of the fact that ability is not there anymore, and you don't want to bring a guy up at 300 feet a minute into the underside of the skid, because that's going to cause big problems.
So there's limit, there's motor limits on the hoist. So if you just drive up as the motor knows that the hoist, just due to the length of the cable it's out, is getting close, it starts to step the right. gearing down on the hoist motor.
That's right. Yeah, I believe the newer models now, I think our one that we have currently fitted the black chrome, I think I could be making up a number here, but I think the number of limit switches that are built into that hoist is somewhere around the vicinity of 14. So there's one on the way out as it gets to a certain number. There's another one where you hit full speed, which is a little further out. As it approaches its outer limit, so all of the cable is deployed, it'll slow down and then totally stop at the opposite end as well. And then likewise, when you're bringing it back in again, as it approaches the skid, you'll get a limit initial slowdown to like a reduced speed. And then the final 2 to 3 feet is actually a reduced speed again. So that's all based on a readout meter inside the hoist mechanism itself. It doesn't actually know how much cable is beneath it. It's just basing on where the position is on the drum and things like that. So if you were to manually cut the cable, the hoist has no way of knowing you've done that, and those limit switches are quite ineffective at that point.
Fantastic. Yeah, heaps of information in there. The next one I might tackle, Dave, and we'll throw it to you, because this is probably the whole reason we're having this conversation, and the origin for your company is back to the dynamic rollout. So do you want to expand a bit on that, and maybe just give the circumstances where that came into play with Dave's death earlier? Yeah,
so I know we're running short on time, but just essentially,
there's no rush on time. It was more I was just conscious of your time. So yeah, in terms of the podcast, don't worry, go for it.
Okay. Yeah, no worries. Appreciate it. Yeah, so essentially that accident was a night rescue operation up at Mount Charleston, fairly high altitude, up around the close to the 9,000 foot range, which again is total normal operation for us, trained to do it, proficient to do it. Weather conditions were pretty good, and it was just a single adult male that had gotten lost hiking around up there on some trails. So I got off trail, eventually got ledged out. So the crew responded, did a briefing, flew out there. It was decided once they got on station, they located him because of the proximity to the terrain. The rotor blades were going to be, within our policy, not super close, but, fairly close to the terrain. So in order to expedite the process, they decided they were going to lower Dave down on the hook and have a rescue strop device, which is a device that's used for a couple of different types of rescues. A lot of it's for water type operations, but essentially what it is, just a device that a rescuer would wrap underneath the arms of a victim and then secure them with a secondary device, and then raise you up with the rescuer. So you go up together, 2 people together. So what they had discussed is to lower Dave, get him on the ground, leave him hooked up, put some extra slack in the cable to allow him to work, and then attach the strop device, and then do a double up kickoff. So basically pick the victim and Dave all at once, and then, slowly as they're recovering him towards the aircraft, just gently sort of fade away from the terrain. And the thought behind that was it was just going to minimize the exposure close into the terrain with the aircraft and the rotor blades. So he was located, Dave was sent down, and everything was going fine. And when the strop was hooked up, the strop was attached to the hook first, And as you mentioned in the beginning of the podcast, how that gear can rotate up and around the gate on the hook, which, as Rob mentioned, if it's non-locking, if a device like a carabiner or something like that can actually get up over the top of the gate in just that position, when tension's put on it, it can open the gate. So the strop was put on first, and then Dave's carabiner was put on second over it. So once he got the victim briefed and was getting ready to be brought up, that's what we theorized happened was Dave's carabiner rotated up and into that position. And when he gave the signal to raise and slack was taken out of the cable and tension was put on it, just as they started to come off the ground and the ship started to just slowly drift away from that terrain, and there was a fairly significant drop off, it popped the gate and he became disconnected and basically fell probably about 300 feet initially before he first hit the terrain, and then continued down a little bit further from there. And the fall was definitely not survivable. So yeah, it definitely, it hits home with us because, like I said, we lost a very dear friend and a very phenomenal SAR officer and just a phenomenal human being. But that was essentially kind of what happened. And then the crew, it took them a little bit of time to locate him. And once they did, one of the smartest things that we did was we actually immediately launched another complete separate crew to come out in a different aircraft, swap roles, and then that second crew continued the mission at that point because the first crew was obviously very affected by what they knew had happened, especially once they located him. So, in a case like that, that's definitely the best way to handle that situation so that, the folks that are kind of, if you want to say their head are no longer in the game, are kind of removed from it, and then a fresh crew is brought in to kind of handle the situation. But yeah, in a nutshell, that's basically what happened with the accident.
Yeah, I can't even imagine being in that crew after that and then still trying to operate. I mean, obviously professional, you got to do what you can do, but that would have just been absolutely terrible. Yeah, it would have been absolutely tragic.
Yeah, it was devastating. Again, and there's a tribute to Dave on our website. There's a video that there's a production company called Mountain Shadows that had been doing a lot of recording at the time. Actually, they were looking at doing possibly a show on the unit and the rescue operation. And they're based in Vancouver, phenomenal group of guys. And they actually took a lot of their footage and they put together an incredible tribute video that we have a link to on our website. So really encourage anybody, if you don't know anything about Dave, go to the website, and if nothing else, just watch that video and read the story about him, just so we can kind of get the word out there. Because in addition to giving really good training and preventing accidents like that, we really kind of feel like if he's always remembered, he's never forgotten type of a thing. So encourage people to do that.
Well, Dave, we might just touch on one more topic, and then we can give a bit more detail about the courses that you guys run, and again, resources where people can go grab some more information. But now moving into NVG operations, what are some of the considerations now for winching?
Yeah, so when it gets into doing hoisting at night, essentially the techniques and the flying are very similar as far as what the approaches look like and what the hoist operator does and how the cable is being run up and down and the gear and all that stuff. That essentially remains the same. The big thing that ends up, that we end up teaching in those courses are, how does the pilot now adjust to fly and do those operations under goggles? And then with the lighting, how does the hoist operator do the job, with just either aircraft belly lights or a hoist light or, basically the reduced lighting to do the hoisting. So essentially what we do remains the same. But from the pilot's perspective, the biggest thing, as I said earlier, it all has to do with reference point. It's much more challenging at night. It can be done very safely if you're trained to do it. But once you get in over the target, you have to have a really, really good reference point. Typically, the hoists are a little bit lower if they're over open, flat terrain, just because as you go up higher, as you can imagine, if there's no contrast and there's no distinguishing features for the pilot to look at, either under the goggles or through the goggles, it's really challenging. You just don't know when the aircraft's starting to move. And the hoist operator will, when we do these types of operations, as I said earlier, we'll tell the hoist operator that we don't have a very solid reference point. So we'll ask them to pick up the frequencies of those calls, telling us, hey, stop left, come right to. So they do it a lot faster to tell us, because a lot of times we just don't notice it as quickly as we would during the day. A lot of the time is just spent flying those same slow, flat, shallow approaches over the target and then picking up the reference point. And then a big part of it is setting up the lights properly. Really, the best thing that you can do is flood the area with light around the area of your reference point. And if the aircraft has belly lights, which they typically do, that'll give you a little bit of ambient light that kind of floods forward, especially if you're in close to terrain. And if you have a fixed landing light, that's going to give you some light as well. And then in almost all cases, you'll have a steerable searchlight. So what I typically do is I will pick a reference point, like say the portion of a rock outcropping, and just have it generally illuminated as much as possible. And then me personally, I prefer to transition and look under the goggles, which if you're close enough, you can do. You can also look through them just fine, but you have a little bit more of a limitation to your depth perception. But that works fine as well. But really the biggest thing is picking a reference point and then setting up the lights properly to be able to see it. One common mistake is to kind of give for pilots out there that have never done it. And if you're just kind of trying to wrap your head around how you do this, one thing that we do right off the bat is we'll fly out there and we'll let the pilot put the light, like the steerable searchlight, on their reference point and then try to hold the helicopter there. Because initially what everybody wants to do is, in theory, if you think, well, if I just keep the light on the object, then the helicopter's not moving. And essentially that's not true. And you can demonstrate this, if you just take a flashlight in your hand and you point it at an object, sitting there in your living room, you can keep the light pointed at the object and you can move around and just keep the light pointed at it and the light remains on the object. So, in reality, you're all over the place and you have no idea because this thing's just sitting there perfectly with the light on it. So for the pilots, that's the biggest thing. It's all about reference points and then properly using the lights. And then as far as the back goes, a lot of the stuff that we teach stems from their equipment that they use. All the lighting has to be compliant. The aircraft has to be NVG compliant. And what I mean by that is essentially there can't be any sources of light in the cockpit or the cabin that are white or that would actually overpower the goggles, because the goggles essentially just take light and they amplify them. So if they take in a lot of light all at once, it basically overpowers them and then the pilots can't see. So all the lighting has to be compliant. The aircraft has to be compliant. And as far as the gear and the folks in the back, one technique that we highly recommend, and it works really well, is having some sort of a light on the hoist itself and then some lights on the rescuers on their wrists. And a lot of folks just use regular chem sticks, like glow type sticks, with just wristbands, like Velcro type wristbands. But if the rescuers crack two of those and actually have, green or red work the best on their arms, it's a huge benefit to the hoist operator to see the hand signals that the rescuers are giving as they go up and down on the cable. And then also there's some aftermarket products that you can actually attach to the hoist itself hook and provide light as it goes up and down. And then, kind of lastly, a workaround that a lot of agencies do, if you don't want to spend the money on an actual light to attach to the hook, you can just take some chem sticks or glow sticks and tie them off with a weak link type of a rope that would break away if it snagged on something, and just crack those. And now the hook essentially has a light source on it. So it makes it a lot easier for the hoist operator to see the hook as it gets into an area, especially if it's confined.
Fantastic. Okay, well, I've got little people starting to wake up in my house, so there may be some background noise as we go on. Dave, and I guess we'll take team with you, Rob, in terms of just talking about the courses that you run and the setup there at SR3.
Yeah, you want me to go first, or Dave, you want to lead things off?
Yeah, Rob, go ahead, buddy.
Yeah, so I think the interesting thing is that we're getting requests from a whole bunch of different people from different agencies and different types of work, and we're starting to see hoisting, particularly in North America, get used a lot more for things like work access, power line maintenance, things like that as well. Just generally getting guys in and out of hard to reach locations, and it's been amazing how diverse the requests have been that are coming in. I think Dave can speak a little more to obviously his extensive law enforcement background. So we do have a heavy interest in law enforcement stuff, especially as agencies start transitioning to hoist-equipped aircraft from not having that capability before. But I think that the big thing we're trying to pass along is that we as a company have dedicated quite a bit of time now to looking at a whole bunch of different agencies and looking at what everyone around the world is doing in all different facets of the industry. And, a lot of guys have come through the industry with one background, and then they've been, whether it be a military guy or a bush pilot or whatever it is that they might have done. And a lot of guys maybe have not hoisted in a variety of different environments too much. I mean, there are exemptions, obviously, but
some guys may have only done SAR, and so to get into the power line work can be a real challenge. And so we try to pay attention to what's going on in all kind of areas of the industry. And then if someone comes to us and says, hey, even if they want to be trained in one particular type of work, there's things that are happening in other areas of the industry that are cross-compatible, and we can draw upon all those experiences from all those different places and people, and ideally try and provide the highest level of course that we can, because we've gone out there and taken the time to get the information from everywhere, so that basically they don't have to, you know.
Okay, so do you want to just list off the types of courses that you run?
So yeah, essentially we on the helicopter rescue side, specific to hoist operations, we have the ability to train hoist operators, rescue specialists, which are essentially the folks that are going up and down on the hook and doing the work on the ground. And then I think one thing that stands us apart with some of the other places that do training is we actually have the ability to train the pilots as well, both day and night if it's required. So those are kind of the three core groups of folks involved in the hoist operators that we train. And then as far as the training programs go, I'll just give you a little bit of an idea. Standard one for, say, 2 pilots, 2 hoist operators, and anywhere from 2 to maybe probably the most we would be able to do is maybe 8 to 10 rescue specialists, but would be in a 2-week course. Those courses typically would be, the first day is going to be all ground school, classroom type stuff where you go over the theory, the legal portions, review emergency procedures, and essentially everything to do with hoisting. The second day, what we typically do is we split it up into 2 parts. The first part is doing mock-ups out in the hangar with the aircraft, letting the people actually work the gear in and out of the cabin. The pilots are included in that as well. And then one thing that we do that's extremely useful is we actually have a virtual reality setup that allows the hoist operators and the pilots to work through the process and emergency procedures together and work on the communication before they actually get into the aircraft, which huge benefit to it because it's, as you can imagine, it's much cheaper than actually firing up the aircraft and going and flying around. So we do that to introduce the basics of the conning commands and that communication between the pilot and the hoist operator. And then after that, we start flying. And there's a variety of techniques that I won't get into that, essentially that we run through for basically a day inland course. And then there's some advanced courses as well that basically run through the same thing, but at night. Essentially, that's kind of a summary of it.
Guys, well, thank you so much. I mean, in terms of a primer to hoisting, that's I'm just looking at it, it's about an hour and a half we've been going for. So I think that is going to be a fantastic resource for folks to listen to, just to get either a quick refresher if people haven't done hoisting for a while, or if you've never done hoisting and sort of looking from the outside in. There's been some really good stuff covered there. So yeah, guys, thank you so much for that. And I guess just in terms of website to find you guys or to find you online and other resources, where can folks go to see what you look like and get more info?
Yeah, so website is sr3rescueconcepts.com, and we're also on LinkedIn and Instagram. We typically put up a lot of really good content. There's a blog on the website that we put a lot of stuff up there, and then the Instagram is actually really awesome. There's a lot of content. We like to really push out stuff, actual just basic techniques that will help people that are doing what we do in the industry to make it safer. So yeah, essentially that's the best source. And then if you want to email Rob or I directly, we can put that in the comments for this episode, and then links to our profiles and bios on the website as well.
Dave, thank you so much. Rob, thank you so much for hooking us up as well. And I'll look forward to catching up with you guys soon.
Yeah,
we really appreciate the opportunity to come on the show. And like I mentioned earlier before we started, a huge fan of what you're doing with the show. I've listened to a ton of the episodes, Mick. So I really think it's a bang up job you're doing. And, honestly, can't thank you enough for doing this. The industry, I think, really appreciates it, because I know I do.
Oh, Dave, thank you. That's great feedback.